Good morning, everyone. I'm Wei Jiaxu. I'm the research director for the Good System Smart Cities, and I'm also the group manager for the Scalable Computational Intelligence Group at Tech. The Good System is a UT Grant Challenge with a mission to developing human AI partnership that can benefit societies. The smart city technologies have great potential to contribute to these missions. So to advance our knowledge and research around smart cities, we have started this lighting presentation every Tuesday morning from 10 to 10:30. So for today, we are very delightful to feature the work from Dr. Tom Benson. Tom Benson is a researcher and a designer who trained in architecture in the UK. Since September 2018, he has been working as a research fellow at the MIT Senseable City Lab. His interest in making cities more livable and sustainable by intersecting architecture, urban planning, and data science. Currently based in Amsterdam, his project involves studying the built environments through large data sets using computational techniques. His talk for today is titled Sensible Cities. Tom, I will turn the mic to you.
Thank you very much for the kind introduction. Let me share my screen. Okay, you can see. Perfect. So, good morning. Thank you for the invite to the talk. It's a pleasure to be here. My name is Tom Benson, as I said. I'm from the UK, and I'm a research fellow at the MIT Senseable City Lab, where I've been nearly for 3 years. I'm currently now based in Amsterdam, so it's a good afternoon to me. But today I'm excited to share with you some of the work that we do at the lab. But first, I want to take you back in time, actually, to 1901. So 1901 was actually just before Henry Ford founded his company. And cars were a little strange back then. But in the same year, a group of French artists were asked to envision the future in 100 years. So actually for the year 2000. And they came up with some pretty interesting pictures. For instance, they predicted automation in agriculture. They also predicted technology entering our homes. And they also invented a Roomba, apparently, as well, 100 years ago. But if you look at the field of mobility, they predicted some very strange things. They were envisioning flying firemen, which I'm not sure is a thing these days. Buses that would go underwater, attached to whales, which I think would be also pretty cool. Or flying police. So clearly they missed a couple of things. They for sure miss this. They miss the prominent role of cars in our society. But more importantly, they miss this. This is a visualization of Lisbon through the lens of billions of data points, visualizing mobility networks in real time. So today we have the technologies that are entering our physical space. Bits are converting with atoms, and that technology and digital data, we can actually explore cities from a different perspective and in turn understand how to improve them. And this is exactly what we do at the MIT Senseable City Lab. We are a team of 40 researchers from various disciplines. We have mathematicians, physicists, computer scientists, designers, architects, planners, social scientists, all from different cultures as well, from places like Sao Paulo, Mexico City, Beijing, Hong Kong, Milan, Bangkok, and of course, England. But we're all coming together to answer one question: how can we improve city living? And what we basically do at the same time is science and design. We want to do social innovation. So we usually get our hands grubby on some data. We try and analyze that data to uncover hidden realities and then go back into the design cycle to understand what we learned from the data and then propose new systems that could become part of urban futures. And we focus on cities because of these four numbers. Cities occupy 2% of the land, 50% of the global population, consume 75% of the energy consumption, and produce 80% of the CO2 emissions. So the big challenges of humanity over the next 40, 50 years, they're urban challenges. So if we can make a difference in cities, we can actually have a very large global impact. And at the lab, we see these two layers. We have the digital layer. This is your digital breadcrumbs, your digital traces, as you would say, which you're leaving behind through your transport card, your bank transactions, your cell phone. And then we use this layer to improve the physical layer, the things you see, the things you touch, and the people you see. So the artificial and the natural are converging, and it's this convergence where Senseable City Lab fits. And to do this, sometimes we have to build our own sensors to deploy an environment. We have built and deployed sensors to monitor bridge vibrations on Harvard Bridge, also in sewers to monitor health in a city through human poo, but also on trash trucks to collect hyperlocal environmental data. But one big question that we have at the lab is, how do we get people engaged with our research? And although we're interested in publishing in top scientific journals, we also have a specialized data viz team where we can create interactive websites and videos as a medium to share our research to the wider public to create behavioral change. And we're always asking ourselves, how can we create feedback loops? And we have found data viz and this visual media as one way of closing this loop. But the first project I would like to share with you is a sort of flagship project. In 2015, the mayor of New York at the time, Mike Bloomberg, he released all the data in terms of pickup and drop off for taxis. And when you visualize this data, you can start to see some patterns appearing, with blue being pickup and yellow being drop off. And it's a unique data set. And here we actually visualize 7 days of the data set to really reveal the real-time nature of this and potential to construct hyperlocal analysis on this. You can start to see how the city is being formed through taxis, pick up and drop off locations, seeing patterns of activity starting to appear throughout the city. And we actually didn't really have a research question formed at this point, but we start to see some interesting patterns appear. We found huge inefficiencies within the system. 20,000 people a year were taking a taxi from one block to another block in Manhattan. And we asked a design question on how can we reduce this and understand how many of these trips could be shared through using mathematics. So we proposed this shareability network model, testing against all the trips in space and time to understand how many of these trips could be joined together with a small delay. For instance, you can see T1 top left on the map and T4 in parallel. These 2 trips could be combined together into one trip with a small delay. And we tested this throughout cities around the world and found that if you have a 100-second delay, you can share 90% of these trips. And 2 interesting findings came out of this research. The first is that we collaborated with Uber on this project, and after which they released Uber Pool and have been collaborating with the lab ever since. But the second interesting finding was that the New York Times came out and said, interesting bit of research, but New Yorkers don't share anything, especially mobility. But now over 50% of the trips are completed by Uber Pool in the city. So it's really creating the behavioral change throughout this research. And that's what you could do tomorrow. But what about what you can do today? And here in this project, Minimum Fleet, we asked the question, what is the minimum number of vehicles needed to serve all the trips in New York City without delaying passenger pickup times? And currently taxi drivers don't have a passenger for 35% of their time driving. So we explored this unknown. We explored this gray zone and aimed to reduce this gray zone and time taxis don't have a passenger. So we built this model and we were able to redirect taxis. Once the taxi driver dropped someone off, they were then rerouted to another location where they would expect to pick someone up, finding these hotspots around the city that I've learned from years of data collected about pickup and drop-offs. And we actually found that you can reduce the number of cars in cities by 40% and still serve the same number of trips just by reducing this gray zone. And you can see here, these are the yellow dots. This is actually the current scenario. This is real data. We also spend a lot of time picking our music, so I hope you're able to hear it. I'm not sure if I shared it correctly. But you can see on the left, this is the proposed model, the blue dots, with 40% less cars on the streets of New York. And again, this is a math problem. How can we use network science to design science through science? Is the philosophy of how we work, designing through science, utilizing not only digital technologies, but also computational methods, machine learning, deep learning. And this system that we propose here is certainly possible with autonomous vehicles in the future. And reducing the number of cars would also have large repercussions in terms of making our streets more livable, reducing air pollution, but also reducing the need for parking. We actually found that private cars sit 95% of the time. And in fact, a single car occupies at least 2 car parking spaces, one at home and one at work, which leads to our cities having large amounts of space for parking. So we speculate on this future of self-driving cars. And to give reference, an American reference, the amount of car parking space in America is less than the size of Puerto Rico, which is a crazy amount of number and space that's been utilized for this. So we built 2 models for Singapore to quantify mobility demand and its relationship to parking based on 2 scenarios. The current scenarios with private cars using 2 car parking spaces, and a scenario where self-driving cars can be shared. You can imagine it can take you to work in the morning, it can take your grandma for lunch in the afternoon, and then it can come pick you back up later on, utilizing the sharing economy of our models. And by doing this, you can reduce the need for car parking infrastructure in Singapore by 84%. As cars will be less idle, and as a consequence, bringing the potential for architects to design better public spaces in these areas. We could have temporary pop-up innovation spaces for designers and for artists. We could build more parks, more greenery, and just overall creating better cities. Reusing this redundant space through the use of digital technologies and computational tools. And finally, moving to the last project that I will share. This is the project, a 5-year collaboration with an institute in Amsterdam and the city of Amsterdam, which is also the reason why I'm in Amsterdam. And historically, the canals of Amsterdam were an essential part of urban transportation. But more recent, with technological advances, such as the automobile, the canals lost its role as an important piece for mobility in the system. So the question was, how can we use technological solutions to bring back the importance of the canals? So our aim was to construct and deploy the first fleet of autonomous boats, turning the waterways into roadways. And as architects and designers, our first question was, what are the user cases for such a technology in an urban environment? And of course, we looked into moving people, creating Uber water taxis. But you can also create on-demand infrastructure, creating dynamic bridges and platforms for markets, events, or even to provide a space for more social distancing. In the morning, it can alleviate traffic management. In the afternoon, it can be a space for workers. And in the evening, it can be a space for families and children to play. You can also utilize these robots to enhance the circular economy food in the city. But you can also move goods, packages, waste, reducing the need for large delivery trucks on the streets, removing the need for the large congestion being created. But actually looking back in the more practical realms of constructing these robots and the technical aspects, we've developed a quarter-scale prototype and the algorithms to make them autonomous, but also they can latch together to create different formations to generate various shapes in order to build a fleet. And this is us testing in the MIT pool. We've also constructed the boats to avoid static objects and also dynamic objects. As you can see here, this is avoiding the bin, which is a static object. And then this is one of our researchers who is the dynamic object, which hopefully is giving our researchers more incentive to make his algorithms work correctly. And by using a combination of computer vision and LiDAR, we're actually able to classify objects and to understand the distance of each one, which we use in the math of actually how they navigate through the canal. We can understand if it's a tree, a boat, a car, and in turn, understand if that object is dynamic, which helps the robot navigate through the canals. But we're always asking the question, what more can we do with this data and wealth of information? We were able to analyze and monitor in real-time structural strength of bridges for its cracks, and also measuring the historical buildings in Amsterdam if they're shifting through time by measuring their distance. And over time, you can start to create this real-time 3D model of the city. Thank you very much. Is there any questions, comments?
It's very interesting talk. Yours is full of the videos.
Yeah, like I said in the initial part, we have a big emphasis on converting some of our complex scientific results into mediums that people can just understand. Like my dad could look at these videos and understand, okay, the goal of this project was to reduce the amount of cars on streets. Like everyone can relate to that. And it's a challenge. Obviously, we have all the publications that are, go into the deep math of actually how it works. But I think one challenge that we face is that we want to create behavioral change, and we think DataViz does a very good job of that, especially with the videos, to create more engagement with the public. Otherwise, it's just going to stay in a journal, and then, I mean, it has its academic benefits, but we feel there's more to this as well. Even with cities and governments, they obviously would be very interested in this research, which we've obviously shared with them. But if we just sent them a journal from Nature, they'd look at it and read it and maybe read the abstract and understand, but get past that, and it's pretty difficult to comprehend actionable change that could be delivered from
it. Okay. So related to that, I have two questions on the minimum fleet problem project we're presenting. So one is my understanding is you're based on the OD pairs, like from historical OD pairs, and then to trying to optimizing the routing, so be able to reduce the vehicle. Is that the case?
Yeah, kind of. I didn't work on that directly, the mathematics behind it. So it was more a showcase of what that project can bring to the lab. But if it's a very technical question, I'm not sure I would be able to answer it. I'm sorry.
Okay. Well, the other one is actually exactly related to what you were just saying. Is I know a little bit more about the audio optimizations, but on the other hand, is if you really want to say reduce fleet in New York cities, it's more about changing people's behaviors rather than just a optimization problem. Is that?
Totally agree. I think this touches the surface of what potentially could happen. I think there's many aspects to it, right? Because we can't just go in there and deploy our algorithms tomorrow on where taxis should be dispatched to in certain times, because there's so many logistical frameworks that need to go through. And this is a challenge that we face. But I feel as though a lot of our research has applied methods to it, and one of the actual minimum fleet project is now become a startup for business. And like I said in the presentation, the potential of minimum fleet is comes mainly with autonomous vehicles. When it's but that comes with a change. Should we have private cars in the future? It's a question. If we don't, we can have much less cars on the streets because people can share and have continuous buses, for instance. So it is a big challenge, but I would also say that we face the same challenge with our hubcap project, the first one that I shared, and about how the New York Times, one of the biggest mediums in the world, came out and said no one will share mobility, and we had to create behavioral change. We had to make it work that actually if you share, it's cheap for you to share, and you can also get from A to B, and it's not uncomfortable, right? The first time I went into an Uber pool, everyone felt uncomfortable. Who is this person, right? The taxi is normally a very private experience if you're with your family or friends. Now you're introducing a randomer into it, but now it's quite normal. I would happily get into a taxi and and hopefully many people would do as well. So I think over time, this research could be implemented to urban futures, but I think it is quite speculative. There's no doubt, and it would require many levels in terms of policies and in terms of from bottom up as well.
There's a Tom. There's a question on the chat from Ryan. So the question is, how do you choose which cities to work with? Do you go with data, or just go with open up RFPs?
Yeah, it's a good question. We have a consortium, so where people, cities, companies, private companies can join our consortium, and then we then work with them on their specific challenges. So, for instance, we're working directly with the city of Stockholm as one example. There's maybe 10, and they've came to us and said we have challenges in terms of segregation, in terms of urban mobility, and we believe that your portfolio of work can help contribute to alleviating some of these major challenges that we faced in the city. So it's really not a case of that we pick. Well, the challenges have to fit our agenda. Of course, we don't want to work with any company that just says we have this technical challenge. Can you come fix it? That's we're not consultants. We want to be creating very interesting work academically, but also in an applied sense. So the conversations more work in parallel together in terms of who we work with. Sometimes people will come with a very interesting data set, and then that means that we can analyze it on Singapore, for instance, which is an example. But in the minimum fleet project that I shared, we started off with New York, and I know I showed New York twice, but actually we did the same analysis for cities around the world, and it was a universal law in our work. So if we don't want to, New York is very unique as well because it has a grid, it's on an island, and we want to make sure that this is not just for one specific scale and spatial structure of a city. So there's no real answer to the question in terms of how do we pick. There's many different ways that we can work with cities, whether they come to us with challenges, whether they come to us with a certain data set, and then we sort of form our direction from there.
Is there something for what happened for Amsterdam?
Yeah, so Amsterdam was an interesting one, actually, because the robot project, the project that I showed at the end, was a very unique partnership because it doesn't really fit within our consortium because it was such a large project, 5-year collaboration. It was a big commitment. And the city actually had an open call on how can we use digital technologies to improve the city. And Carlo Ratti, the professor of my lab, he submitted a proposal to actually do autonomous vessels in the water. And Amsterdam came back and said, wonderful idea, can we pursue with this? So that was actually like an open call that we submitted to, and then the partnership formed after that, which I think was a very exciting part for us because we actually, in terms of the update on that project, actually last week we built and deployed the full-scale robot. I wasn't able to show it today, but hopefully if you follow our Instagram page, you can start to see some exciting updates from the project.
Awesome. And that was fully funded by City of Amsterdam, right?
Yeah, fully. I would say 90% confident, yes. I don't know the details of the contract, but yeah, it's fully funded by the City of Amsterdam. Stockholm is definitely fully funded by them. So this is normally how the partnerships work.
Awesome. That's very impressive work.
Thank you. I appreciate that. Is there any more questions?
Real quick, I wanted to ask about, I know you mentioned you weren't super involved with the technical side of things, but I just wanted to ask you why you picked LiDAR over computer vision for the robot.
Yeah, it's a good, well, actually, maybe I wasn't clear. We actually use a combination of both. So we actually merge computer vision and LiDAR to understand the actual trajectories of the boats and how to navigate and avoid certain aspects. But we're actually finding, this is current work that we're developing and there's no concrete answers, but we're actually finding that we can actually do it solely with LiDAR data, actually, to actually avoid objects instead of using computer vision as well. We're actually figuring out that to create autonomy, computer vision maybe not be necessary. But we also want to use the computer vision in a sense to create other findings from the city. Navigation is obviously one aspect of the data collection through LiDAR and the images. But what more can we do with collecting images? We can actually find, maybe we can find the leaves of trees and understand how they change through different climates and seasons, and then start different findings from that. But we do use a combination currently, but we are looking at different methods that maybe just uses LiDAR data.
Okay, yeah, Cool. Thank you.
Of course, and actually all the publications are on our website. We have robot.org and we have sensible.mit.edu, where we have all the projects aligned. I shared 3, I think we have 100 on our website, and each one of the projects is complemented through an academic publication, which will go much deeper into what I did, to be honest. So if you do have more questions, please do reach out though, and I can hopefully help, or I can put you in touch if you were curious.
Yeah, certainly. That'd be awesome. Thank you.
Of course.
Okay, so if there's no more questions, and I want to thank Tom again to give this wonderful presentations, and thanks for everyone joining. And with that, we conclude our today's talk. We will have another talk on next Tuesday. And if you want to know more and please follow us through our website, the smartcity.tech.utah.edu. And Tom also posts his live website there, and I can add that into our website posting as well. Thanks for everyone joining. Hopefully to see you next time. Bye, Tom.
Thank you. Thank you very much. Bye-bye.